Okay, we are moving along, and we are dealing with 8M2, lesson 11, definition of congruence, and some basic properties. Today, what we are going to cover is we're going to talk about how everything we've learned in 8M2, lesson 1 through 10 has been leading up to this concept of congruence, and how congruence is the same thing as taking an object and translating, rotating, and reflecting it into another object. If you do one or all three, two or three of those rigid transformations, you will end up with a two congruent objects. I'm going to talk to you, I'll show you this. We're going to talk about a method by which you can always identify two congruent objects and map them onto each other and describe the exact transformations you need to use. And then we will go into some homework help. Okay, let's move to our magic pad here. Okay. Sketch pad. Okay, so let's just talk about the definition of congruence. Okay, we have been talking about transformations and rigid motions. And those rigid motions are, again, translation, which is like sliding and leaving the top on the top and the bottom on the bottom. We talked about rotation, which is twisting in place. And then we talked about reflection, which is laying down a mirror or a line and just flip-flopping the object across that mirror. Now, another thing that we learned is that we can, when you do these one, two, or three of these things, these things maintain the length of sides, and B, the measure of angles. Now, the key to congruence is it's another definition. Congruence means that two objects have the same length of sides and same measure of angles. And it turns out that two objects are congruent if and only if you can translate, rotate, and reflect one to get to the other. Two objects are congruent if and only if you can perform one, two, or three of our basic rigid transformations on one object to map to other object. Okay. So let's just kind of box all that up and see if we can make some sense of that, and then show some examples. Okay, so these two objects that I've drawn, here, let's just go to a different color just to kind of call it out. This is object 1 and this is object number 2. Are these two objects congruent? Let's ask that question. And the answer is these things identify same length sides, right? This denotation means that this side is the same length as this side. This demarcation of 2 lines means that those are the same length. This means the 3 means those are the same length, and this 4 means those are the same length. So we have an object with the same length sides, and similarly, we have some markings that say that this angle is the same as this angle is the same as this angle, and this angle is a right angle. This angle here is a right angle. So we can start to, let's just label our sides here. Let's just label them. Well, angle 1 here that is off of this vertex. So this would map to this one. Just making sense, right? These points, these vertices here, right here, must map to each other if these objects are congruent, because this angle is the same. So let's then travel along here to B. So if we travel from A down to this right angle, we'll go B. And so I'm going to have to do the same thing on this object. Let's go from A prime to this side here, and we're going to go B prime. We travel alongside 1 from B. This is working out nicely, and we get C right here at angle 2. And the point that now is on the inside is D prime over here and D over here. So we can see that AB and A prime B prime are both the same length. B prime C prime are both the same length because they have that marker of 1. C prime D prime are 4. C to D is 4. And then A prime D prime is 3. So those are the same lengths. And then our angles. Angle A is the same as angle A prime, both 1. B prime and B are both right angles. C prime and C are both the same because they have the marking of 2. So we know, so these are congruent. By definition, they're congruent because they have the same length sides and the same angles, right? They have the same length of sides and the same measure of angles. Now, what that means is that we can actually perform a translation, rotation, and or reflection, one or more of these, to actually map this one object onto this object. So, because they are congruent, we can do these things to map one to the other or the second one to the first one. And we're going to talk a little bit more about that. And this is what you did in today's lesson. So I'm not going to do it with these objects, although by the end of today's lesson we could. We are instead going to go and show you today's lesson and show you a trick that will always work, or a strategy for always identifying 2 congruent objects and then mapping one to the other. So let's go there. So here is today. This is kind of like today's lesson. I kind of tried to draw these objects by hand. So the question is, are these congruent? Well, the first thing I want to do is I want to just kind of label them. So this pointy thing is going to have to be point A, right? So this will be A, and this will be A prime, and this will be A double prime. This point over here is going to be B, right? You travel along this flat side and you'll get to point B prime. And you travel along this side, you get to point B prime. You travel, now this thing on the end of this curve, this point is going to have to be C double prime, and this one will have to be C prime, and over here it's point C. So the question is how can I map one object to the other object? So it asks first to map S1 to S2. Now let me give you the strategy. here is the strategy that will always work. This will always work to show congruence via transformation. Right? Transformation via rigid transformation. So the first thing that we're going to do using our strategy, and just watch this, follow this. The first thing we're going to do is we're going to translate our object so that one point matches up. Just one of the points. We're going to match, so A to A prime, or B to B prime, or C to C prime. The second thing we're going to do is we're going to rotate about the matched up point so that another point matches up. And then 3, if we need to, we are going to reflect about a line that contains those 2 points. And this will always work. This will always work. And let's see how this always works. So let's just follow our steps 1, 2, 3. So the first thing I'm going to do is I'm going to select this object and we're going to transform it. So we're going to translate it. So translating, that means we can just move it like this. And we're going to move it so point A matches point A prime. And now notice I didn't draw these perfectly, but let's just match up those 2 points like this. Okay? Okay, wait a minute. I got to do this one little sneaky thing. Whoops. Oh, wait a minute. Let's go back. Undo. Oh my goodness. Give me a break. Just give me a second here. History. Let's go back to here. Uh-oh. Just a second. Here. Uh-oh. Where did my object go? Frustrating. Okay. Oh my goodness, this is making me mad. All right, we're just going to recreate it. Hang with me while I recreate it. And it's not going to be, may not be perfect. But let's just recreate it like that. And the other thing I need to do here is, why did it disappear on me like that? Oh, I'm getting trouble from trouble. Okay, here we go. Okay, so now what we're going to do is we're going to take this object and we're going to match up points A. And now what I'm going to do, so that's we've translated our object. We've translated the object. Now the second thing we're going to do is we're going to rotate it about this point here. We're going to rotate it about the point so that another point lines up. So no, we have not, still haven't lined up another point, haven't lined up another point, haven't lined up another point. But now we've lined up that second point. And remember, my drawing wasn't exactly perfect. So that's why it's not exactly on top of each other, but we've lined up that second point. Okay. And now you can see that if I just, now I've lined up B prime and A, and now if I just were to reflect, if I were to reflect across this line, let's draw the line, the reflection line. I think you can see it, but if I were just to reflect this across this line here, right? If I were just to reflect it across the line that goes from here to here, then then these would be the same. Now, what I want to do is I want to take this other, so we're going to move this object away here. Whoops. Let's get rid of that guy. Let's move that one. Let's move this guy away. Now what we want to do is we want to translate this, or we want to transform this object into this one, and we're going to use our same strategy. We're going to translate the object. So let's do our translation. Just let me humor me for a second. Now what we're going to do is we're going to rotate the object. Remember, the first thing we do is we translate it. The second thing we do is we rotate it. Oh, and look, it lines up right on top. Again, my drawing wasn't perfect, which is why it's not exactly on top. But you can see that you translate and then you rotate. And in this case, we don't have to reflect because the objects just line up. Okay, we're going to see this again. Let's go to Geogebra. This is a little bit, it's kind of hard to do it on this scratch pad here, but let's cut over to Geogebra and let's try this same tactic. Now notice down here, I've written our steps here, right? I've written our steps that we need to try. Translate to match one point, rotate around the match point, and reflect. And remember, there is always more than one. Remember, there is always an infinite number of ways to transform. But this strategy here will always work. Not sure why that doesn't work. Okay, so I think you can see, look, if you were just to draw a line here, look at this. So if we were just to draw a line right here, you could see that you could actually reflect this object as triangle ABC, and it would become triangle FDE. You can see that, I think. But let's just make sure that our strategy here will still work, even in this simple case. So what would our strategy say to do? Our strategy would say to identify the sides that, or the two angles that match. So let's just do that. So we would take B to D. These are our right angles. I think you can see that angle B and angle D, or vertex B and D, are the ones that match up. So we can just translate this object, boom, right onto this one. Okay? Bam. And now we've translated to match one point. Now the second thing we do is we rotate to match a second point. Well, we already have our second point. After we translated, we have, notice, after we translated, let's make these be exactly the same size again. Okay, so BC, notice that C matches up to E. So if I translate, I don't have to do step 2 in this case because I have two lines, 2 points that match up. So remember, sometimes we need to do 1, sometimes we need to do 2, sometimes we need to do 3, sometimes we need to do all of them. But in this case, we had to do step 1, and watch. Now we only have to reflect, right? So we can reflect. If we take that and we reflect it, that first triangle, and we reflect it, sorry, and we reflect it along this line, ABC will become DEF. Right? Okay, so in this case, we only needed to do step 1 and step 3. Now, let's look at a more sophisticated example, and let's try. This is your homework help, by the way. This is homework help. Let's do a sophisticated polygon that looks like this. Come on, lay it down right there. Okay, so let's select it and let's make one of them. I'm going to make them, whoops. I'll make that one a different color. I'll make it orange. And we'll start with this one and we'll make it green. Green means go, orange means, I don't know what orange means. Okay, so the question here is, are these objects, whoops, this one comes like this. The question is, are these objects, are they congruent? Now there's 2 ways we can show congruence, and we're going to do it both ways. The first thing is can you match up these objects on top of each other? So if I go from, let's start with M. M, obviously, because it's on the inside, has to match up with point R. Okay, let's, so it has to, and if I go from R to N, that would be like going from M to I. Are you following me? So R maps to M. So let's just write this down here. So M maps to R. And then if I go along this short side, I go from R to N. So N, whoops, not N. Let's go back to freehand mode. So M is R, and then I, let's go like this. Here we go. Let's kind of make a box here. And then we'll go I maps to N. Because I went from R to N on this one. I went from M to I. And so if I'm at I, I has got to be J. And if I go, I'll keep following in, J goes to O. And those are the same length, right? N to O. And I to J. So J now goes to K. J goes to K. Whoops, screwed up again. So M, I, J. So M, I, J, K. And R, N, O, P. K goes to P. And now we're at P and we're at K. So K goes over here to L, and that's this long side, L. And so that's got to be the same as Q. And then Q goes back to R. So if we do our vertice map, let's draw our vertex map. And so on object 1, we have M, I, we're following it around, J, K, L. And on the other one, we go from R, N, O, P, Q. This is a little bit easier to read. Right? So we go, so let's just follow this again. M, I, J, K, L. M, I, J, K, L. K, L being the long side. And we go R, N, O, P, Q. P, Q being the long side. Now let's look at these angles. Angle M is the inside one. Angle I is this 45-degree angle. And so is angle N. O is this 90-degree angle here. And so is angle J. And angle K is this 90-degree angle. And so is angle P. And Q is this little skinny angle out here on this point. So we think that these objects are congruent. It looks like we have a mapping. Each side is the same length, and each angle and vertex is the same length. So we should be able to translate this guy to match, translate, rotate, and reflect this guy to match to this guy. So what are we going to do? I'm going to choose to map, I'm going to choose to map L to Q, because these are kind of on the outside. It's going to be easy for me to do. So watch what I do. I'm going to translate this along a vector. Watch. I'm going to take my I'll draw the vector that I'm going to translate by. I'm going to translate this guy all the way down here. So watch how I do this. We're just going to translate him, boom, down to here. Now what I need to do is I need to rotate. That's the second step to show that two objects are congruent. Now remember, you are doing all this on transparency. You have taken this object that's over here, and you have just, with a little editing trick, okay, rotate around point. There we go. And we're just going to rotate this guy 180 degrees until we match our other point. And now notice we've translated and then we've rotated. And what's our last step is to optionally reflect, and we do need to reflect. So we're going to need to make a line a line of reflection, and I'm going to draw that line right now. And then what we need to do is our final step is to reflect this object about that line. And we've matched the two objects. So notice in this case, we had a difficult object, but we labeled it and we identified that we thought they were congruent. Then we went to our steps of translation, rotation, and reflection to match them up. Okay. So let's return to our screen share or to our visual. Okay, we're back. So again, what did we learn in this lesson? Maybe it was a little bit, maybe I didn't do a great job today, but I think the key essence of what we learned today is that we connected all of our rigid motions of translating, reflecting, and rotating, and explained that if you can do those things on one object, that you end up with another object, that those two objects are congruent. So conversely, if you find two objects to be congruent because you can look at all their sides and angles and see that they're the same, then there must be a set of rigid translations, rigid transformations that you can use to get from object one to object two, or object two to object one. And we saw that in GeoGebra. We also saw it on our drawing paper. You typically will be using it or demonstrating congruence, though, using your transparencies, mimicking the same actions that we used on in this virtual world. Okay, thank you. We'll see you next time with lesson 12, and we'll get on with actually some new learning that's a different kind, a little bit different, a little bit of geometry, but very powerful and very useful for you. All right, talk to you later.